Hello everyone, my name is Haedong, and I am a PhD student in the Department of Industrial and Manufacturing Engineering at Penn State. Today I will present the work done with my advisor Dr. Hu Yang, the research about county-level contributing factors to opioid-related overdose deaths in the United States. First of all, let me share my screen. So let me start with introducing the motivation of this research. The opioid crisis is one of the worst public health problems in the history of the United States. As this graph shows that more than 40,000 people died from opioid-related overdose deaths in only 1 year, 2017. The worst part of this epidemic is that the number of deaths has ever been increasing so far. It has never decreased. That means that efforts to curb the problem have not been very successful. Our research starts from that fact. So this is our question. Why the current approach does not work? And one interesting fact drew our attention that the current approach has focused on restricting prescription opioid supply. So the researchers or policymakers so far were interested in prescription opioid and to restrict their supply. For example, there were opioid prescription guidelines or dose limit drug take back days programs. But, but that was not enough. So we need to get a better understanding of the dynamics of the epidemic. The better we understand the dynamics of the epidemic, the more effective interventions can be suggested. And we narrow down our focus onto 2 points. So there we are interested in demand side dynamics. So which factors drive people to abuse opioid and illicit opioid, for example, like heroin and fentanyl. Let me go back to the previous slide. Number of deaths from heroin start increasing from 2010, and number of deaths from fentanyl start skyrocketing from 2013. So these two illicit opioids are now the main driving factor of this epidemic. So there is an urgent need to do research on these illicit opioids, not just for prescription opioid like OxyContin. So we made up our research statement. The first one is that we want to investigate county-level contributing factors to opioid overdose deaths in the US. So we want to check the social determinants that might social or risk factors that drive people to abuse opioid. By doing that, we want to get a better understanding of demand-side dynamics of this epidemic. And second, to make an inference between number of deaths and social features, we use the statistical linear models to make an inference. And we developed this model for different types of opioid. As I said, we used heroin, fentanyl, as well as all types of opioid. So to examine the general trend. So we developed 3 models for that purpose. This is the data we have collected. So there we divide the features into 3 groups. One is demographic group and socio-economic group, and the last one is healthcare environment group. And this table in the paper provides the basic statistic of features we have collected. And this is a modeling part. We used a linear model to make for the sake of interpretability. To be specific, we use a multi-level mixed effect model because this model is suitable for nested data with grouping variables. Our data have a natural hierarchy structured geographically with states and counties. So it makes sense to use a multi-level mixed effect model in our case. In this model, in addition to just coefficient term in simple linear regression, mixed effect multi-level mixed effect model has a so-called random effect term that is z in this on this slide, which is formulated as a normal random variable. So that's why this model is called a mixed effect model, because there are random effect model and fixed effect model. So there are two effects that they are mixed in this model. And we also dropped some features that have a high correlation with a cutoff value 0.9 with other features. For example, rate of age over 65, that feature has a high correlation greater than 0.9 with odds dependence ratio. So we dropped the rate of age over 65. And this is a modeling result here. So as this table shows, we developed 3 models for different responses, and it provides fitted coefficient and their 95% confidence interval. For quick reference, we visualize this result in the next slide. So one thing that I want to point out and emphasize is that this result is not the end. It actually is a starting point for the further investigation. So these results can be interpreted in many ways with according to readers' interest, and that does not provide some solid conclusion, but it will give you general trend or that give you some starting point to further investigation. We hope that this result can be used in that way. And there are two points that I want to emphasize about this result is that some features behave differently according to responses. That means that some features behave differently for heroin, fentanyl, or types of opioid-related deaths. For example, feature 13 is order dependence ratio, and heroin or only heroin has a negative correlation for this feature. And another thing is that income and education level are actually positively correlated for all three types of responses. So we made a hypothesis that this is because opioid epidemic is severe in urban area, because we first assumed that the higher income and education level, the lower the number of deaths, but that was actually opposite. And then we thought of the region, and then we made a hypothesis is that the level of urbanization has a very significant effect on this epidemic. So that will be our future work. So we want to investigate on level of urbanization and occupational distribution, as well as demographic distribution we use in this research. That will be our future directions, and the data and codes used for this research will be available in this GitHub repository. So thank you for your attention. These are our contact, and I would like to thank Center for Healthcare Organization Transformation CHOP for supporting this research. Thank you for your research again. Thank you for your attention again, and I hope you have a good day.